Now let's have a look at two-way tables or contingency tables. Now we've seen these a little bit already. We've used them to display conditional probability, but they're also useful when we're analysing data to spot whether two variables might be related or not. Now we can't get a definite answer as to whether they're related, but it's a good first step investigation. So let's look at this as an example. If we ask everyone in the class whether they prefer cats or dogs, and we want to see if this is related to their gender, whether they're actually boys or girls, we could put our data into a two-way table and see what we get. Now, drawing this up, we also can easily come up with some totals. So for this group of people, which we've just made up the data for, we can see that 2 boys prefer cats, but 4 boys prefer dogs. So the total number of boys must be 6, and the total number of girls must be 16. But we can also see that the total number of people that really like cats is 9, and the total number of people that prefer dogs is 13. We can also double check that if we add the cat lovers and the dog lovers together, we should get 22. This will be the same as if we add the boys and the girls together, because everybody has been counted in 2 different ways, as being a boy or a girl and also liking cats or dogs. So we should be able to get the same total either way. Now when we go to answer conditional probability questions, it's quite straightforward. We could say, what's the probability that if we choose someone at random, it's someone that loves cats? Well, if we're talking about the whole class, there's 9 people that love cats altogether out of 22 people. So it would be 9 22ths. Whereas if we were doing a probability question that was conditional, in other words, we said, what's the probability we'll choose someone that loves cats, given that they're definitely a boy? Well, then we're putting a spotlight just on this row of the boys. We'll say, well, how many boys are there? There's 6. And how many of them like cats? 2. So the chance of choosing a cat lover just out of the boys is 2 out of 6, or 1/3. And the chance of choosing a cat lover, given that we know we've chosen a girl, means that we're now ignoring the rest of the information except this row. There's 16 girls, and 7 of them like cats. So the chance of choosing a girl that likes cats, given that we know we've chosen a girl, is this. Now, do more boys like dogs than cats? Yes. And do more girls like dogs than cats? Yes. So we can't really say whether or not liking cats or dogs more is related to gender, but what we can do in this case is answer a bunch of conditional probability questions really easily.